Hi everyone. Today we will look at conditional statements. You can see some terms and definitions on the left. The main thing we will work on is the if P then Q statements, and then the converse, inverse, and contrapositive of it. Now let's look at an example. Here we have if x equals y, then x squared equals y squared. So let's label the P and the Q part. Now let's look at the converse of that statement, which is switching the P and Q part. So that would be if x squared is equal to y squared, then x equals y. Now let's do the inverse, which is if not P, then not Q. So this means if x not equal to y, then x squared is not equal to Q. The contrapositive of the statement is if not Q, then not P. So for this example, that means the contrapositive is if x squared is not equal to y squared, then x is not equal to y. Next example. Here our conditional statement is if it is a square, then it is a rectangle. So the P is a square and the Q is a rectangle. Now let's do the converse. Remember that is switching the P and Q. So that would be if it is a rectangle, then it is a square. The inverse is writing the statement as if not P, then not Q. So in this example, the inverse would be stated as if it is not a square, it is not a rectangle. Now the contrapositive, which means we do if not Q, then not P. So we would write the statement as if it is not a rectangle, it is not a square. Do the converse, inverse, and the contrapositive make sense here? In this example, we have if a plus b is 0, then a is equal to negative b. The converse will then be if a is equal to negative b, then a plus b is 0. The inverse will be a plus b is not equal to 0, then a is not equal to negative b. The contrapositive is if a is not equal to negative b, then a plus b is not equal to 0. Now let us take a look at proofs with algebra. Some helpful terminology is written on the left. Basically, when doing this, we want to justify all steps that are done. So we start with what we are given, which is our equation. Then we distribute to get rid of the parentheses. So we state what we used on the left side. Then we simplify by combining like terms, which we state as our reason. Then we want to isolate the x term, so we subtract from both sides, which is the reason we write on the left. Similarly, the next step we use the subtraction property to get the x term isolated. Then we use the division property and simplify to get x fully by itself. In this example, we will play around with properties of congruence. There are 3 triangles labeled with equal sides. Using the transitive property, we can see that segment AB is congruent to segment DE, and segment DE is congruent to segment GH. Therefore, by the transitive property for congruence, segment AB must be congruent to segment GH. Using the same example above, we can look at the symmetric property of congruence. Using the symmetric property of congruence, we have segment AC is congruent to segment CA, segment DE is congruent to segment ED, and segment HI is congruent to segment IH by the symmetric property of congruence. In this example, we have 2 triangles right next to each other. By the reflexive property of congruence, we can say that segment BD from triangle BAD is congruent to segment BD from triangle BCD, again by the reflexive property. Now let's use some of these properties to prove another example. Given angle ABC is equal to angle NBN, we want to prove that the measure of angle 1 is equal to the measure of angle 3. Using the angle addition property, we can write the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2, and angle MBN equals the measure of angle 2 plus the measure of angle 3. We can use the substitution property to set them equal to each other. Then, using the subtraction property, we get that the measure of angle 1 is equal to the measure of angle 3.